Okay, question number 18. Franco and Carol went to a bakery to buy desserts. Franco bought 3 packages of cupcakes and 2 packages of brownies for $19. Carol bought 2 packages of cupcakes and 4 packages of brownies for $24. Let X equal the price of 1 package of cupcakes and Y equal the price of 1 package of brownies. Write a system of equations that describes the given situation. So, first, let's start with Franco. Franco spent $19. I always start with the other side because that's a blatantly obvious fact. I know he spent $19. Now I have to do a little work to say what did he spend his money on. So he bought 3 packages of cupcakes. Cupcakes are represented by X, so 3X. He also bought 2 packages of brownies, so 2Y. And here, notice I left out the operator because I want to make it very clear that we have to put a plus in the middle because he spent his money on both of those things, cupcakes and brownies. So let's talk about Carol. Carol spent $24 total. Her money was spent on 2 packages of cupcakes and 4 packages of brownies. And again, we're going to add those 2 values together. That's our system of equations. So now we can go to the TI Nspire graphing calculator and actually graph these 2 equations and make those lines on our graph. So on my graphing calculator, I'm going to go New Document, add a graph page, and then delete the equal sign. Neither one of these is in y equals mx plus b form, so I want to type them as relations. 2x plus 4y equals 24. And that's my first graph. Now, I'm going to go ahead and graph this line on my paper and then graph the other line. So menu 5, 3. I set my trace step to 1 and say OK. Now, when I do menu 5, 1, I can actually steal these points and put them right on my graph. So the very first point I have is 0, 6. From there, my next point is 2, 5. My next point is 4, 4. I always try to label my y-intercept, and I want to have points along the graph to demonstrate that I'm actually graphing these appropriately and make sure that you're using your lattice points. The nicer your graph looks, the better your chance you're going to get full credit for your hard work. Now, we'll go back to the calculator, get my next points. I only want the lattice points, so 6, 3, 8, 2. Now, to finish it off, the very last point we're going to have is 10, 1. And I also want to make sure that that point is on my graph. So when graphing, attention to detail is very important. I've got my points labeled, all my dots are on lattice points, and now take a ruler to connect your dots with a nice, clean, straight line, and label that line with your equation. Now we can go back to the calculator, press Tab, and graph our second equation. So 3x plus 2y equals 19. The key here, when I graph this line, now instead of doing just a graph trace, I want to trace all to graph both lines. My first line is already on my paper, so I want to go and find points for the second line. So the first point I find is 3, 5. So I'm looking down here at my second relation. I have 3, 5, and I'm moving to the right. So the next point is 5, 2, followed by 7, -1. So I can't go below the x-axis because my graph is only in the first quadrant. So to get from 3, 5 to 5, 2, I go down 3, right 2. So to get to the point that came before, I go left 2 and up 3, and that's the point 1, 8. Now, when I connect these dots, that's what my line looks like. The name of that line is 3x plus 2y equals 19. So that's the name of my line. So once we complete our graph, make sure that both lines are labeled and that we have enough points to demonstrate that we graphed this exactly like it's in our calculator. We're told to find the point of intersection. So we go back to the graphing calculator. Now, when I look at this graph, I don't see a good point of intersection on the graph. I know I have these two lines, and I know they meet somewhere, but that's not a lattice point. So this isn't whole numbers. It's not like $5 and $3. Something different's going on. There's change involved. So menu, choice 6 to analyze the graph, choice 4, we want the intersection of these two lines. So I set my window, I have a lower bound, I press enter exactly one time, then I drag past the intersection to find the upper bound. And now I'm going to put this point into my graph, 3.5, 4.25. So now I've labeled the point of intersection, but the statement says justify your solution. So my recommendation, the best justification I can make is to store these values in my calculator and then show that it works for both equations. So let's go to a calculator page. So home screen, new doc, say no to drugs, add a calculator page. So the first thing I want to store is the value of x. So I have 3.5, control, and the VAR key is the store command, and I'm going to store that as x and press enter. Now for the y, I have 4.25, again, control var key, and store for y. Now, I want to type in that system of equations again. When I press enter, notice that my first equation is true. So I type my second equation, that's also true. So now what I can do is steal this and put this right into my document as a response to my question. So this is how I show the work to justify my answer. If those are both true, then this is my solution to my system. So one last detail I might add to this is a brownie costs $4.25 and a cupcake costs $3.50 to explicitly state my answer to the question so they can't get nitpicky on me and take away a point. And this is absolutely 6 points for question number 18.